On the left side, here we have a series, and the result is equal to 3 to the power of n minus 1 divided by 2. We are going to prove this mathematical expression by using mathematical induction. In mathematical induction, we will prove it in two steps. The first, we are going to show that it is true for n is equal to 1. So it is step 1. We are going to prove for n is equal to 1. We can see here on the left side, we are going to get here it is 3 to the power of 1 minus 1 will be 3 to the power of 0, and it is 1, the first term. On the right side, we will get here 3 to the power of 1 minus 1 divided by 2. It will be 2 divided by 2 is equal to 1. So we can see here that actually the left side is equal to the right side, it is equal to 1. And step 2, we are going to assume that it is true for n is equal to k. By assuming that it is true for n is equal to k, so it means our expression will be 1 plus 3 plus 3 square plus blah 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 plus 3 to the power of k minus 1. It is equal to 3 to the power of k minus 1 divided by 2. We will call this as Sk, sum of this series until k. We are going to get here Sk plus 1. So Sk plus 1 will be equal to 1 plus 3 plus 3 square plus blah 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 plus 3 to the power of k minus 1 plus the term of k plus 1, so it will be 3 to the power of k. From our previous expression, we have here that actually this will be equal to 3 to the power of k minus 1 divided by 2 and then plus 3 to the power of k. And then we can see here that as k plus 1 is equal to, we can simplify them. We are going to get here 3 to the power of k minus 1 plus 2 times 3 to the power of k divided by 2, and then we are going to move it here 3 to the power of k plus 2 times 3 to the power of k minus 1 divided by 2. And then the next, it is 2 times 3 to the power of k. Here, actually there is 1 times 1 times 3 to the power of k. So 1 plus 2 will be 3 times 3 to the power of k minus 1 divided by 2. So this expression will be 3 to the power of k plus 1 minus 1 divided by 2. We can see here that the last form we have, this will be similar if we substitute n is equal to k plus 1 to n. So it means that by assuming that it is true for n is equal to k, it will be also true for n is equal to k plus 1. So we can take conclusion that since we have proof that it is true for n is equal to 1, and then by assuming it is true for n is equal to k, we can prove that it is true for n is equal to k plus 1. So because we have show that it is true for n is equal to 1, and then we can assume, by assuming it is true for n is equal to k, we can prove that it is true for n is equal to k plus 1. So it means that it is true for n member of positive integer. Okay, thank you.